These videos are going to be for October 19th and October 20th, and we're looking at the inverse trigonometric functions. That's a key word for what we're going to talk about today. And then we're also going to be able to explain the restrictions to their domains and ranges, respectively. And at the beginning of class, what we talked about is what is an inverse. And when we talked about that, a lot of classes we did something like, well, what if it was 5 plus x equals 7? And a lot of people said we're going to subtract 5 and get x equals 2, because if it's a positive 5, it's like being added. So I can subtract 5 to do the inverse. They undo each other. And that's the idea behind inverse functions. Inverse functions in general, they are entire functions that undo the action of another function. And that's the key. That's a key idea. We're not going to talk too much in terms of too many aspects of inverse functions, but we are going to look at one major one today. I guess we did today. And what we did is, as a case study, we looked at x squared and square root of x. So if I were to plug in 1 into x squared, the output would be 1. If we were to plug in 2, the output would be 4, 9, and 16. If I take these values and make those the x values and plug those into the square root function, square root of 1 would be 1, square root of 4 would be 2, 3, and 4. And what we talked about here in class was, if you look at the two table of values and look at similarities, what we notice, what we talked about is here our output, or these are like our y values. Those became our x values here. And the x values here, those became the y values here. Excuse me. And that happens because these functions are inverses of each other. Inverses of each other. So because they are inverses of each other, the x values here should become the y values here. The y values here should become the x values there. And what we talked about even more than that, if we're talking about the x values that a function can take, what we're really talking about is the domain. So here, this function's domain, when we take the inverse, it's related to and should become the inverse function's range. Similarly, here, we're looking at the range, this is really compact, but we have the range here. That range became our inverse function's domain. And that's huge. That's really key here, is that the domain and range, they should switch. The domain that's here should become the range here. The range that's here should become the domain there. And that should happen because they are inverses. That's a key thing. They are inverses. Now, let's go ahead and start talking about defining sine and its relationship to arcsine, which it's inverse. Or another way I could write arcsine is sine inverse, or sine to the negative 1 power of x. That's just a notation that says sine inverse. And these values here for the sine table of values, these are all coming from our unit circle. That's where that's coming from. But similar concept. Here, our input, or our x values, will become our y values. Our y values become our x values. So what's happening here, what's happening here, our y values, those become the x values that we're going to input into arcsine. So here I'll have 0, negative 1, 0, 1, 0, negative 1, 0. And the x values, because these functions are inverses of each other, the x values switch. So 0, negative pi, negative 1, negative pi over 2, 0, 0, pi over 2, pi, 3 pi over 2, 2 pi. So again, the x values become the y values become the x values become the y values. Now we're going to look at the graph of arcsine. This is a really important piece of what we did on October 19th or 20th. So I'm going to go ahead and notice on our x values, it's 0, -1, 0, 1, 0, -1. So we're oscillating between -1 and 1. So on the x-axis, I'm going to put 1 here and -1 there. And on our y-axis, it's like -pi over 2, 0. It's going in increments of pi over 2. And so I'm going to kind of do something that looks, well, so this will be 2 pi, 3 pi over 2, pi over 2, -2 pi, -3 pi over 2, -pi, and -pi over 2. And if you have, if you're still writing, if you have your sine function, you can actually take that out. And the sine values, when we graphed it, they oscillate between -1 and 1 on the y-axis. Now that's on our x-axis. And what used to be on our x-axis for sine is now on our y-axis because the x and y switch. The x and y switch when we're dealing with inverses. And now we can plot these points. So if I plug in 0, I should get out -pi. So 0, -pi. If I plug in -1, I get out -pi over 2. So -1, -pi over 2. 0, 0, so that's here at the origin. 1, pi over 2. 0 pi, -1, 3 pi over 2, and 0, 2 pi. We could also go down here and do -1, -3 pi over 2, and 0, -2 pi. Now I'm gonna use a dotted line. We're not finished with this guy yet. This is going to be our function arcsine of x. We're not finished with this guy yet, but I'm going to go ahead and draw a dotted line through these points. And this is what our arcsine graph looks like for now. So there is our arcsine graph. Now, if you stop here and don't go on to the next videos, you're going to be really, really confused. And it's not going to make sense in the future why we're shortening certain things. So please make sure, if you have questions, or rewind, if you need to pause, whatever, that's fine. But please make sure that you watch the next video to make sure you see that, because we're not done with arcsine yet. We have to do other things to it. So go to the next video to see what we have to do to arcsine.